true projects. In this video, we are going to explain about fast clustering by affinity propagation based on density peaks. Introduction. Clustering is discussed in the project, which is the process of grouping data based on similarities. Clustering is utilized for two reasons: to get a basic comprehension of raw data and to shrink a vast volume of raw data. The project introduces two clustering methods: affinity propagation clustering AP and density peaks and distance based clustering DDC, both of which have been effectively applied in a wide range of practical issues. The project presents DDAP, a two-stage fast AP clustering method that can significantly increase the AP algorithm's efficiency while obtaining comparable clustering performance to the original AP. Objective. The objective of this project is to propose DDAP, a novel clustering algorithm that addresses the drawback of the existing clustering methods: affinity propagation and clustering AP and density peaks and distance based clustering DDC. The suggested technique intends to increase the AP algorithm's efficiency while providing equivalent clustering performance to the original AP. To drastically condense the scale of the similarity matrix, the project presents DDAP, a two-stage rapid AP clustering technique that selects a limited number of candidate exemplars based on two quantities of each data point in DDC. The incomplete similarity matrix is then used to implement message forwarding. Two synthetic datasets, 9 publicly available datasets, and a real-world electronic medical records dataset are used to test the proposed approach. The results show that DDAP can achieve comparable clustering performance to the classic AP algorithm while improving computing economy noticeably. Requirements. The requirements of the project are hardware requirements and software requirements. In hardware requirements, we have operating system Windows only, processor i5 and above, RAM 4GB and above, hard disk 20GB and above. Software requirements. In software requirements, we have Python IDE with 3.7 version. Methodology. To implement this project, we have designed the following modules. The first module is upload dataset. Import the dataset such as the car and iris dataset, which will be used for clustering evaluation. Second module is pre-process dataset. Clean and pre-process the dataset to ensure they are suitable for clustering. This involves handling missing values, normalizing or scaling features, and transforming categorical variables if necessary. Third module is run affinity propagation algorithm. Implement and execute the affinity propagation algorithm on the pre-processed dataset. This algorithm involves iteratively updating responsibility and availability matrices to determine exemplars and cluster assignments. Fourth module is run DDAP clustering algorithm. Implement and run the DDAP algorithm. This involves several steps. Construct a potential exemplar matrix based on distance metrics. Identify highly similar points to form a compressed matrix. Compare the similarity of the compressed matrix points to other data points. Assign cluster labels based on similarities and form clusters. Fifth module is comparison graph. Generate visualizations that allow for a direct comparison between the results of the affinity propagation and DDAP algorithms. These could include a graph comparing the execution time of both algorithms, a graph illustrating the accuracy of clustering results from both algorithms. Execution. For the execution of the project, we need to open the code folder. This is the code folder. This is the dataset folder. To implement this project, we have used car and iris dataset. This is the main code file. This is run.batch file. Instead of executing our project in the command line interface, we have created Windows batch file to execute the project. Double click on run.batch file. A graphical user interface will pop up. This is the graphical user interface which we have created using Tkinter library in Python. Using this GUI, we will interact with the project. Click on upload dataset to upload the dataset. Select car and open. So here we can see that the dataset is loaded and the dataset contains both numeric and non-numeric values, but non-numeric values are not accepted by clustering algorithm. So these non-numeric values must be converted to integer ID. So click on pre-process dataset to process the dataset. So here we can see that the dataset is processed. Now click on run affinity propagation algorithm to get its accuracy. So here we can see the affinity propagation accuracy and affinity propagation computation time. And we can see each record is assigned to which cluster ID. For example, first record goes to cluster 0, and similarly all records are grouped into different clusters, and records with similarity will be in same cluster. For example, in above screen, record number 1 and 2 are in 0 cluster, so they have similarity. Now click on run DDAP clustering algorithm to cluster data with DDAP. So here we can see that we got the DDAP accuracy and DDAP computation time. So here also we can see that the labels are given as cluster label 0, 1, 2, 3, etc. Now click on comparison graph. So this is the comparison graph. X-axis represents the algorithm name and Y-axis represents the accuracy and computation time. So here from this graph we can say that AP has less accuracy and more computation time, and DDAP took less computation time with more accuracy. Now close the graph, click on exit, and the final conclusion of the project is this project solves the clustering issues given by the affinity propagation and density peaks approach due to the example finding. Affinity propagation has high temporal complexity, whereas density peaks accuracy declines with massive data. The DDAP algorithm is intended to address these concerns. DDAP generates prospective exemplars based on distance, resulting in a compressed matrix of points with strong similarity. DDAP decreases temporal complexity while maintaining accurate clustering by comparing the similarity of this matrix to additional data points. Using DDAP in conjunction with affinity propagation, the project shows better accuracy and reduced execution time, confirming DDAP effectiveness in resolving both accuracy and efficiency problems in clustering jobs.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.